Here we go. Aw. So this is the same as the limit as x goes to 1 of x minus 1 minus ln x over what?
ln x times x minus 1.
Minus 1. Okay. We now have one quotient, correct?
It should be ln x minus x.
No, it should be, because you're multiplying this one by x minus 1 over x minus 1, and you're multiplying this one by ln x over ln x. Right? Okay, so we have that. So what could we do now?
Apply L'Hopital's rule.
Why?
Because as x approaches 1, the denominator goes to 0.
0, and the top goes to 0 as well. That's correct. So if we can apply this, take the derivative of the top, what do you get?
1 minus 1 over x.
1 minus 1 over x all over. What do you have to use on the bottom?
Quotient rule.
No quotient rule.
Product.
Product rule. The derivative of the first times the second plus the first times the derivative of the second. Now what do you check? Hey, can you use L'Hopital's rule? You automatically can see you cannot. Why not?
Because the top one is
No, fraction has nothing to do with it. Well, hold on. Maybe. I don't know. You're right. Not necessarily. Sorry. Excuse me. It could. So how do you know if L'Hopital's rule applies?
Plug in x. Plug in 1.
That's the action to find out if. What are you looking for?
0 on the top and bottom.
Or
Infinity.
what are those called?
Determinate.
Indeterminate forms. You're looking for an applicable indeterminate form. The top goes to what?
0.
The top does go to 0. So what about the bottom?
The bottom goes to 0 too.
Does it go to 0? Okay. So could we use L'Hopital's rule again?
Yes.
Yeah, we can't plug in 1. We already know that. So let's apply it again. So if we apply this, what does the top become? Oh, do you know what you can actually do to this? There's actually, hold on, I'm just going to call a timeout on this and give you a random applicable something you can do to this. There's a nice piece of algebra you can do. You could multiply this whole thing by x over x. If we do that, what does the top become? All over. No, it turns into x minus 1 plus
X ln x.
x ln x. So all we did right there, I'm just giving you the stupid,
Really easy.
but there's a million really, like, you could multiply by pi over pi. Yay, that gets you nowhere, right?
Now we have pi.
Now we have pi in there. It's going to be the theme of this class. We're going to put pi to every single question. Okay, so,
Yeah,
but what's,
horrible field of
but
view.
look,
See our next
what's
test.
nice now? Yeah, you can envision your next
You
test.
don't have fractions inside the fraction.
Fractions are irrelevant. It doesn't matter if there's a fraction. It's,
That's nice though.
what's the, what'd you say, Matt? Can you plug in 1? You always check if you can plug in the actual value you're going towards, right?
No. It shouldn't exchange
Really?
the function. It's still
No. Hold on. If I gave you this right here, x minus 1 over x squared minus 1, can you plug in 1 into that? No. But if I factor this and I cancel it out, can I now plug in 1?
Yeah.
Yes, you can. So just because you've done something fun, there's a removable discontinuity, essentially, is what we're saying. So therefore, we're trying to plug that removable discontinuity. We're asking ourselves, have we plugged it yet? Not quite. Why did I multiply by x there? Well, maybe it would be you'd be able to evaluate it, but now what's a little nicer? The derivative is a little nicer.
Yeah.
We can apply L'Hopital's rule. We'll say LH. The book uses H. I like using LH. What do you end up with? The limit as x goes to 1 of 1. Hey, nice. Over
1
plus the derivative of the first times the second plus the first times the. So you end up with the limit as x goes to 1 of 1 over 1 plus ln x plus what? 1. And what's that going to be? 1 over
2.
1 plus 0 plus 1, which is 1/2. Nice.
Damn.
So let's just rate this right now. This one is how, let's say, annoying. Why? Not really because of the calculus, because of the algebra.
So if
That's going to happen. You're going to need to know tricks like that. Theoretically, you shouldn't have to do this, but it helps. It makes it so the derivative is a little easier to compute. It's not make or break, but you just have to ask yourself, can you apply L'Hopital's rule? Yes. take a derivative, take a derivative. What rule are you not using when you take the derivative?
Quotient.
Do not do the quotient rule. And then when you have to do the quotient rule, don't just do L'Hopital's rule. Yes. Find a common denominator. What's the common denominator going to be? X cubed. So what are we going to end up with? The limit as x goes to 0 of sine of 2x plus ax cubed plus bx all over what? X cubed. And we want that to equal 0. Can we use both sides of this? No. You're trying to show it. You want it to equal 0. Be very careful about how, like if you want something to be true, be very careful about how you use both sides at the same time. We're only using one side right now. So we want that to equal 0. What rule now applies to this? Why? Why does L'Hopital?
The top and bottom equals 0.
The limits of individually the top and the bottom both go to 0. Okay, so what can we use? Go like this. LH, what do we do to both the top and the bottom? What's the derivative of sine 2x?
2 cosine of 2x.
What is it? 2 cosine 2x plus what?
3a.
Plus what? B all over
3x squared.
3x squared. Okay, let's take a look at this. As x goes to 0, we want this thing to go to 0. As x goes to 0, this thing goes to 0. So this thing gets really, really, really small, right? This thing is getting really, really small. What's cosine of 0? 1. What do you think? Cosine of 0 is what?
1.
1. Okay, so this thing right here is going to what? What is this going to?
2.
That's going to 2. Okay. This middle thing is going to 0. This thing is going to b. B isn't changing with respect to x. B is not changing with respect to x. This is going to
0.
So if we want this whole thing to go to 0, what are we going to have to make sure of?
B is equal to, you think it's 2?
What?
B will cancel out the value of 2 cosine 2x.
You know that b is going to have to b plus, you know that the limit as x goes to 0 of b plus 2 cosine 2x is going to have to be what?
0.
You know that that has to be 0, right? So therefore you know that the limit as x goes to 0 of b plus the limit as x goes to 0 of 2 cosine 2x has to be 0. But we already know, what's the limit as x goes to 0 of b?
B.
B. So you know that b plus, and what does this go to?
2.
2 equals 0. So what does b have to be? Negative 2. So now we take again, we take this. We're stuck here, but now we know. What's the only added in thing we know?
B is equal to 2.
B is equal to 2.
Like,
Negative 2, thank you. So this equals minus 2. But now, as x goes to 0, this whole thing, the top goes to 0 and the bottom goes to 0. So what can we apply now? L'Hopital's rule again. So you apply L'Hopital's rule. You're going to get the limit as x goes to 0 of, what's the derivative now?
negative 4
Sine 2x plus 6ax all over
6x.
6x. Okay, we want that to go to 0, correct? Well, this is going to go to 0. What's sine of 0? 0. So both of these already go to 0. So bottom already goes there. So what can we apply again? L'Hopital's rule again. So now we have the limit as x goes to 0 of negative 8 cosine 2x plus 6a all over 6. And we want that to go to 0, right?
Yep.
So therefore we want the limit as x goes to 0 of what to equal 0? The top. Negative 8 cosine 2x plus 6a. So that means the limit as x goes to 0 of negative 8 cosine 2x plus the limit as x goes to 0 of 6a has to be 0. What's the limit as x goes to 0 of 6a? 6a, right? And what's the limit as x goes to 0 of this right here? You sure?
Yep.
Mm-hmm. So you know that this has to be 0. So 6a has to be 8. So what is a? 4/3. And we already know that b is negative 2. That's it. You have to keep on stopping and asking yourself, what do we want to end up with? What do we want to end up with? Oh, we've guaranteed that. We know that b has to be negative 2 because in order for this to continue, we need to make b equal to -2. We plug it in, and then you keep on going, and you end up with, oh, why use L'Hopital's rule on this thing right here? There's a constant in the denominator. The denominator is a constant. It's not 0 or infinity. It's not an indeterminate form. So we ask ourselves, how do we make the numerator equal to 0? And it's when a is equal to 4/3.
What's negative 8 cosine?
I asked them this yesterday. This was on a quiz. That's a two input, one output function. X and Y are the inputs, and the output is going to be Z, right? So the question is, as X, Y goes to 0, what does that go to? Well, look at this. Let's look at it this way. Let's make x squared plus y squared equal to some u value, right? So if the limit, what's the limit as x, y goes to 0, 0 of x squared plus y squared is what? Is 0, right? So what's the limit as x, y goes to 0, 0 of u? 0 as well, right? They're both going to 0. So this limit is actually equal to the limit as u goes to 0 of u over the square root of u plus 1 minus 1. These limits are the same. X and y, when they go to 0, x squared plus y squared goes to 0. You set it equal to u. It's the same exact thing. The point is, what's easier algebraically to deal with, this or that? This is a lot easier to deal with. You actually should be able to do that limit right there. Can you?
It would be 0 over 0.
You're right. So let's use L'Hopital's rule. So what's the derivative of the top? 1 over 1/2 u plus 1 to the what? To the negative 1/2 times 1, minus 0, right? And it's the limit as u goes to
0.
0, right? So what does this equal? 1 over, this goes to 0, 1 over what?
1/2.
1/2, which is 2. You just did it. Absolutely. The point is, you can make substitutions like that. That is a great way to simplify things. You just have to be very careful about those substitutions. In this case, it's the same. As xy goes to 0, x squared plus y squared also goes to 0. So you let it equal u and say, okay, u's going to 0. Does it really matter how fast you're going to 0? No. When you say go to 0, it means get infinitely close to 0. As long as you can get infinitely close to 0, you're getting infinitely close to 0. As long as you can get arbitrarily close to something. Yeah, exactly. Exactly. For example, if I get 2/3 of the way to a wall, and then 2/3 of a way to a wall, and then 2/3 of a way to a wall, what's the limit? If I get halfway to the wall, and then halfway to the wall, and then halfway to the wall, and then halfway to the wall, what's the limit? The wall. Can I ever get to the wall?
No.
Can I get arbitrarily close to it?
Yeah.
Either way, right? So if I have to prove there's different ways. Do you understand that, everybody? The approaches actually don't matter as long as you can get arbitrarily close. It's kind of cool.
Some Greek philosopher
Record of 2x minus 3 over 2x plus 5.
Oh, you divide by the...
Do you remember how you approach that? You would multiply by like 1 over x over 1 over x like this. So what does that equal? It's the same thing as the limit as x goes to infinity of 2 minus 3 over x over 2 plus 5 over x, right? You see that?
Yeah,
and then what do each of these go to? 0 and 0. After a while, you don't have to keep on saying that. You just yes, it's the leading coefficients. Same power and the same leading coefficients. For example, if this was 4, what would change?
Then it would be
2. Okay, are we okay so far? So do you agree that this is the indeterminate form 1 to the infinity?
Yeah. So you have to use
2 steps. What do you have to do first?
Turn into logarithm.
Can you give me a sentence? I'll buy a vowel, a verb, an adjective, something.
Log form?
Yeah. Take the what of both sides.
Natural log.
Yeah. Why is natural log?
Because less letters.
Less letters, and E is really cool. You like E. E is cool. It doesn't explode, right? Generally speaking. So what are we going to do here? We say this. Write this out when you start this. We know that the limit as x goes to infinity, I'm writing the original question. You need to start with this so I know what you're starting with. Of this is going to be equal to y. It equals something. What are we going to take of both sides?
Natural log.
The natural log. We're going to take the natural log of both sides, and we're going to get ln of 2x minus 3. Sorry, not ln. What am I missing? I did this like 6 times yesterday. The limit of x going to infinity of 2x minus 3 over 2x plus 5 to the 2x plus 1, and that equals ln of y. So when we're done with this, we're going to have ln y, and then we have to, remember, we have to change it from, it's not 4, it's e to the 4th. What was the magical thing we could do next that you guys bought into?
Just take the limit.
You can switch those two. You can do the limit. You can the natural log of the limit is the same thing as the limit of the natural log. Because you do that, you can then take that exponent and. So I'm going to skip kind of a step here, and I'm going to take this and do the limit as x goes to infinity of 2x plus 1 times ln of 2x minus 3 over 2x plus 5 equals ln y. You with me so far? What can you do next? Someone raise their hand when you know. What can I do to simplify this before I do any calculus? What can I do next? Simplify, 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 simplify. What can I do? I don't like division. What can I do?
Turn from ln of that to ln 2x minus 3 minus ln.
Yeah,
of
division
plus
is
subtraction.
subtraction.
Oh, well,
Why do we like doing that? Because eventually we're going to have to take a...
derivative.
Yeah, eventually you're assuming you're going to have to take a derivative. And even if you're not taking a derivative, what do you like avoiding?
Quotient rule.
You really like avoiding the quotient rule, right? So this is ln of 2x minus 3 minus what? 2x plus 5 equals what?
ln y.
ln y, exactly. Okay. What now? We can only, hold on a sec, this is exactly what I would do. If you gave this to me on a test right now, this is exactly what I would have done. I would assume that we're heading towards using which rule? L'Hopital's rule. What's the challenge, though, with using L'Hopital's rule right now?
Getting it into a form where you can use L'Hopital.
What type of form is that? Indeterminate form, right? Our indeterminate forms are either like 1 to the infinity or 0 over 0 or infinity over infinity. We no longer have any division here, right? This is going to get big. This right here is getting really, really big. That's getting big, but they're going to cancel it. So this whole thing is going to 0, so you have like infinity times 0, right? Do you agree with that right there? You have infinity times 0?
Yeah.
Wait, so you're saying subtracting infinity from infinity equals 0?
It could, maybe, but we don't have an indeterminate form that matches that yet. Our indeterminate forms are 0 over 0, infinity over infinity, 1 to the infinity. What were the other two? There was 2 more here yesterday. Do you remember what they were? What were they? Do you remember?
Infinity to the 0 or
Yeah, let's check here. Let's go back and check. It's fine. We can go back and check because I honestly can't remember from yesterday which ones I gave you. Let's see here. It was, ready? There were 2 more. Right there. Infinity to the 0 and 0 to the 0 to the 0. So it's 0 to the 0 and infinity to the 0. So we have 0 to the 0 and... Does this thing match any of these forms?
Nope.
Not yet. It does not. It doesn't look, honestly, it doesn't look like we're going to get to one of those. It looks like we're going to get to one of these. We did a cool trick when we had 2 things multiplied together. Multiplying by x is the same thing as dividing by what?
1 over 1.
1 over what?
So multiply by x equals something divided by 1 over x.
Exactly. So you can change this into the limit as x goes to infinity of what? Well, what's our top going to be? ln of 2x minus 3. 2x minus 3 minus ln of 2x plus 5. And we're not changing the value, so we're going to do this over what? 1 over 2x plus 1. We haven't changed anything, have we? We're still in what land here? Are we in calculus land still?
Yeah.
Kinda, but inside calculus land, what are we maneuvering with? Algebra. We're just maneuvering with algebra. Okay, so now the question I'm going to ask is, can we apply L'Hopital's rule? What does this go to? 0. And what does this go to? And the way you can more concretely think about this is as follows. We'll go back up here. This right here, what's the limit as x? We know that the limit as x goes to infinity of that fraction is 1, right? What's natural log of 1? 0. So is this an indeterminate form? Yes, this is an indeterminate form because what is it? 0 over 0. So what can we do? L'Hopital's rule. This guy was a pretty hardcore guy, wasn't he? So let's do the derivative. Flattening it out helps us do the derivative, right? Are we using the quotient rule here? No. Say it with me on 3. 1, 2, 3. No. What's the derivative of the numerator, Jackie? Yep. 2x minus 3 times what? Times 2 minus what? Yep. Yeah, you're just doing the 2, right? Because you have those 2's that are the derivatives. All over what? To the what power? To the what power? Times what? 2. And keep in mind, what does that equal? It's really important that you keep on doing that lny. It happens all the time. You get to the end, it's like, yeah, 4, and you're so happy that it comes out to a nice number that you're like, I'm done. Are you done?
Nope.
They have that little thing floating out there. Yeah, what are the things that cancel? A lot of 2's cancel here. That's kind of cool. Correct. And let's just simplify this a little bit and see if we end up with something that we can actually, hopefully we get to a point where we can plug stuff in, right? Goes to infinity of 1 over 2x minus 3 minus 1 over 2x plus 5 all over negative what?
2x
Plus 1 to the negative 2. And this is equal to ln(y). Let's pause here for a sec. You have to be real careful here. What do you think we should do next? Any ideas?
Try to plug in.
Yeah, be careful. We can't really can't plug this in, but let's, ready? I'm telling you about algebra. No. I like that. So look, ln of x minus 1, I like it when your harmony works real well. This is the same thing as making negative 2x plus 1 squared and putting it on top, right?
Mm-hmm.
Dividing by negative x, put it on top. This is times this, right? 2x minus 3 minus what? 2x plus 5. Are we okay so far?
Yeah.
All I've done is I bumped it up top, right? That's all I've done. What could I do with these 2 fractions here? Common denominator, right? So what are you going to end up with? Limit as x goes to infinity of
8 over
negative 2x plus 1 squared. This is still there, right? It's going to be 2x plus 5 minus 2x minus 3. And what's the common denominator going to be?
2x minus 3 times 2x.
2x plus 5, right? Do you agree with this?
yeah.
You agree with that, right? ln(y). So what does that turn into on top?
8 over
Well, hold on. What cancels here? The 2x's. And so what are you left with? You're absolutely right, Fitz. You're left with what?
8.
8. So you're left with, let's just look at this, the limit as x goes to infinity of negative 2x plus 1 squared times what? 8 all over 2x minus 3 times 2x plus 5 equals what? ln(y). You notice how I'm skipping lines here so you can read between? Yeah, good. What type of equation is this? There's a proper name for it. What's that called? Rational function. Thank you. It's a polynomial over a polynomial. What's the power of the numerator? 2. What's the power of the denominator? So we're heading in the right direction, right? It's kind of cool. So let's do this out. We're really only interested in the leading coefficient, but I'm going to do the whole thing out. So you end up with a limit. Oh, and see this negative? I'm just going to go like this. Yay.
Because you can.
That's correct. You end up with 4x squared plus 4x plus 1 times 8 all over what? 4x squared. How many x's? 10 and minus 6 of them. So how many? 4x minus what? 15 is equal to ln(y). Yay, we're cruising. Let's multiply it out. Negative 1 limit as x goes to infinity of 32x squared plus 32x plus 8 all over 4x squared plus 4x minus equals ln(y). So what does the left side become? Negative what? Negative 8 equals ln(y). So what does y equal?
What? Wait, what?
Ooh!
What?
We have the same power here, right?
Yeah.
So the only thing that matters are the
Coefficient.
the leading coefficient, right? What's 32 over 4?
8.
And there's that negative right there. You
Yeah.
took that out just so I wouldn't lose it. So keep in mind here, can these be long?
Yes.
Yeah, they can. Absolutely.
Different colors.
You like color.
Yes.
Yes, I do, sir. So what did they do first? They took the ln of both sides and simplified a bit. Right? They dropped that down to the front. You see that? So this right here, does that look familiar?
Yeah.
It's about the same, right? They then did the exact same thing we did, correct? You see what they did? What's the magical part of that? Look at the denominator. You see that denominator? So they did the exact same thing, right? They then took the derivative. See, that's the H-mean, that means L'Hopital's rule right there. And they got the same thing we did, but they put it back together. Well, here's the thing. Hey, did they get the exact same thing we did? Does this look familiar?
Yeah.
Yeah, absolutely. Hey, look, they just did this dividing by x thing, right? To get 8. The point is, what they're showing you is the end step to all the simplification. Are they showing you any of the algebra in between?
No.
No. The only reason ours looks longer is because A, my handwriting is bigger than their nicely typed stuff, and B, we showed how you actually algebraically get each of those things, and also why you're allowed to do that. You need to see that there are indeterminate forms, because can things look like they are indeterminate forms and they're not? Yes, and the biggest risk there is you're looking at it, you're like, oh, my tells rule, so I'm going to spend my time doing derivative, potentially get nowhere, and then go back and realize what?
I can plug it in.
Yeah. You're going to get angry if that happens. So if you're going to use L'Hopital's rule, you have a hammer, make sure you need the hammer and that you can actually use the hammer, that you're not just like nailing Jell-O or something, right?
Okay.
Find that limit, be careful. So we can skip a few steps here and we end up with ln y is going to be equal to
X times
the limit as x goes to infinity of
X times ln x minus
xm, like that, right?
Mhm.
Correct? Brought it to the front. So what can you do to that?
good.
Yeah. You can break it, or you could just do this originally. This kind of makes it a little easier to see why L'Hopital's rule applies. This would be ln of x over x plus 1 all over 1 over x, like that, correct?
Yeah.
It's easier to see that that's an indeterminate form, I think, because this goes to 1, so ln of that goes to 0, 0 over 0, indeterminate form, 0 over 0. So now what can you use? L'Hopital's rule, right? You can use L'Hopital's rule at this point, LH or H, whatever you want to use. Flattening it first makes it easier to do the derivative, though, right? So we're going to use L'Hopital's rule, but we're going to make this before we do that. Before we use L'Hopital's rule, let's do a little bit of algebra. This is equal to the limit as x goes to infinity of ln x minus x plus 1 all over x to the negative 1, right? Now we use L'Hopital's rule, we end up with the limit as x goes to infinity of 1 over, I'm writing 8s instead of x, it's weird. Infinity of 1 over x minus 1 over x plus 1 all over what? To negative 2, right? What did you do at this point, Fitz?
Brought up negative x thing to
The top, right?
yeah.
So pretty much the same
And
thing we
took out
just
the
did.
negative sign.
Exactly. So you end up with x squared times 1 over x minus 1 over
X plus 1, and then you common denominator.
common denominator this thing. Limit as x goes to infinity of x squared of x plus 1 minus x over x plus 1.
And
Luckily what
the
happens?
top just goes from
That just goes to 1. Right, exactly. So you end up with negative limit as x goes to infinity of x squared over x squared plus 1
plus x.
plus x. Thank you. Exactly. Plus x.
And then if you go to infinity, it's still going to go down.
Well, yeah, the way you could show this, though, the way you could break this down even further, just so you know, that's equal to x over
X plus, yep,
x over x plus 1, right?
because an x comes out of all.
Mm-hmm. Exactly. So, you know, if you did this properly out, you could multiply by this, right? Do you remember this from your pre-calculus days, maybe, or at the beginning of this class? You end up with a negative limit as x goes to infinity of what? 1 over 1 plus 1 over x, which is definitely negative 1. So you know that ln y is equal to, so y is equal to e to the negative 1. We feeling decent about this? Decent, kind of, maybe, sort of? Okay.